Okay, for people who are joining this live stream, the topic today, and people who are here, the topic today is error handling and code robustification. So this is primarily a project that Christopher is doing to try to understand, but basically here's an example of a goal. Take a random function that has been submitted to the function repository that does almost no error checking. What is the minimal path to getting it to do decent quality error checking? Often you have code where something goes wrong in the middle of the code, a missing is generated, a failure object is generated, and the whole thing generates some pile of symbolic garbage and goes crazy. The question is, how can we do better? And how can we learn from sort of developments in programming languages over recent years to sort of invent a scheme that that's more promising? And Christopher has a thing when he sent me something here, but I think my favorite current names for two of the important constructs are enclose and confirm, but we can use guard and contain as well. Let me explain what I understand the current concept to be. So the issue is, let's say it's called confirm. Okay, the idea would be you have a confirm of expa, and if expa is a failure, then that will propagate to the nearest enclosing enclose. So this might be f of whatever, some deeply nested thing, right? And then the result of this will be that the enclose will get, as soon as the confirm is hit and as soon as the confirm fails, it will basically throw out to the enclosing enclose, and this will then return a failure object representing what happened inside that confirm. Is that a fair statement?
Or the enclose will. Yeah, I mean, sure. I mean, the basic idea is just that you have a function that's similar to echo in that you can sort of put it into code without significantly changing its structure. And the point of that function is that it just checks whether its inputs are basically some sort of failure, and then there are probably different versions of this that detect different types of failures. And if it is a failure, then it essentially does something similar to throw and catch and throws you up to the nearest enclose, I guess you can call it. And otherwise, it just passes through like echo, and it doesn't change the course of valuation.
And so the idea is that there are various different forms of confirmation that could be done. An alternative name is guard. There are many possible names. But so an example of confirmation would be, did it generate a message? If it generated a message, then fail out to the enclose. If another one would be, what's this, guard evaluated, confirm evaluated?
That one is guard evaluated or confirm evaluated is by far the screwiest. But that, I think, thinking about how that could work is a more complicated question.
Right. So the idea here is that confirm evaluated conceptually is, did the thing evaluate? But let's see, what are the other forms of this?
Wouldn't that sort of be just that its head is no longer, that it now has a different head?
Well, right. So what the way that's implemented right here is it basically, it's, hold all complete function, and then it just checks. It just checks if after you unhold it, did it change, right? But there's infinite screwiness because, like, for example, let's say I have a pure function, and something you can write. For example, if you wrote a pure function of guard evaluated of hash ampersand, and then you apply that pure function to something, that will have different behavior than if you run guard evaluated of something, right? Because it depends on if it will be evaluated before it gets inserted into the confirm or the guard or whatever it's called. So there's a lot of screwiness to this.
Right. I mean, I would say that in practice, when I want to know if something is evaluated, I check that the head is no longer the head I know I stuck in there. Right,
okay,
because
right,
because if I also had additional arguments, right, if I do f of 2 plus 2 and the result is f of 4, then sure, it's changed, but that's probably not the result I wanted. I probably wanted whatever, F to evaluate to something.
You're giving a heuristic for what, and by the way, the thing that one will realize as soon as one gets deep into this is there are many things where it will be somewhat heuristic. And this question about you're giving a heuristic which we can then make precise. By the way, there's a question from Sander on the live stream. How does this differ from throw and catch?
Well, I think that the main difference between this and throw and catch would be that if you want to use throw and catch for essentially error handling, you have to significantly change the structure of your code. In that, one of the standard ways that people, take a function and give it better error handling is you take your code and then you basically write it in a procedural way inside of a module or something like that with a bunch of variables and stuff. And then you just have if statements and you just say, oh, if it's broken, then throw every so often, right? And so this is basically equivalent to that, except that it means that you would hopefully not have to change the structure of your code that much. You don't have to turn it into this procedural thing.
So for example, let's do an example. So let's say we say guard of, I don't know whether one of us, this is guard, what can I use? Can I use?
You'd use guard message probably. Or you could use guard pattern.
Why is this coming out blue?
Did you run the other notebook? Are you sure you're in the same context and the same kernel and the same application?
I think so. Is it does this notebook got its own context or something?
No.
I am very confused here.
By the way, of course, this implementation is, hacky in some ways. It's calling throw and catch in some weird way.
All right, let's
well, it must have a different kernel.
Why don't you just press, Command N with that selected so you know that it's not a different version. Okay.
Weird.
Did you try running it? Maybe it's just the syntax highlighting is broken.
I didn't try running it. No, nothing.
No.
Okay, so I'll run it in this notebook. It's very weird. Okay. So here, okay, by the way, somebody is making a bunch of background noise. So let's just see what happens. If I just say guard of 5, it says, okay, 5's okay. But if I say guard of missing, it'll say, okay, big mess there.
Yeah, that should be better, but yes.
Okay, so then if I say contain guard of missing, then I'll just get a failure object.
Right.
Okay.
So basically, if there's an error, it propagates the error up to the contain or the enclose.
But so if I say guard, can I map guard over a list?
You could, yes.
So in this case here,
normal guard doesn't have any weird attributes. Some of the other guards do. I think guard message is hold first or something like that.
Right. So the idea here is, if anything is screwy, if the direct contents of a confirm or a guard are missing, then the thing throws to the outer enclose or contain or whatever it is. So people understanding what we're saying here?
Yes.
So
I missed a little bit in the beginning. What is it that it guards against? Messages?
No, there are different forms of confirm. Confirm is a slightly preferred name here. So confirm or guard on the initial version, that just the thing on its own, all it does is to say, is what's contained in here a failure object or a
more generally, right? So
presumably something like missing queue or failure quue.
Yeah,
like missing or failure queue.
Exactly. So there are right now in this notebook here, there are I think 4 or 5 different guards. So there's guard test, which checks whether it's basically like a cert. You give it a function and it checks if that function returns true.
But
Guard
it's
pattern. Yeah.
It's specific values. you know, so failure and missing.
No.
Well,
That's the default case. That's the default guard.
There are several different functions. So there's one of them is called guard test, right, which is different from just plain guard. And guard test, you give it a second argument, which is a function which it checks against.
Can I curry it like this?
Right now, no. Yeah,
Okay.
you probably should be able to, but
okay.
Yeah.
All right, fine.
And there's also similarly, there's guard pattern, which is the analogous thing, but for patterns and so on. So plain old guard.
I see. Now, so there's a predicate pattern, and then there's a hardwired failure.
Yeah.
Stephen, can you evaluate question mark guard star?
There you go. Oh, guarded is another thing which we'll talk about.
That's a more complicated thing.
Does guard message also guard failure? Would you do guard message around guard failure if you wanted both?
Is that if there is a message?
Yes.
Yes.
Right.
Yes.
If the enclosing thing generates a message.
Right. It'll be common that you want to do messages and failures. So we should have a single.
Right. So I mean, one thing is
you don't have to double.
Well, I mean, right. What exactly? So I mean, one question is, for example, the default guard. You know, the default one could also look for messages. Right now, it doesn't.
I think the factoring of exactly what, what exactly the heuristics should be for each one of these, and how exactly this collection should be factored, is not clear yet and needs input. But the first issue is the whole framework here.
So the whole framework says guard detects one of these, it jumps you out to a contain.
That's correct.
Oh, okay.
Does it have tags like catch and throw?
It probably should.
It absolutely should. Otherwise, you'll run into issues where you write a function using guard and contain, or and it takes input that somebody provides their own thing that has its own guard, and they have their contain outside of your function, and then things get caught at the wrong level.
Yeah,
yes, that's ugly. That would be bad.
I mean, it would be nice if the code assistance system, for example,
because presumably at contain level, you can decide to take action and do something to recover.
Exactly.
Yes, yeah, so you can. So there's right now the way it works is there's a second argument you can supply to contain, which is a pure function, which essentially is given a failure object, which contains certain information about what was inside the guard that failed, and then it can try and by default it's just identity, and so it returns the failure object. But you can have other things. So there's an example here, for example, where the contain is inside of a select, and it will always return false if the guard fails.
So implementationally, is it done with catch and throw, or?
Yeah, right now it is. I mean, the implementation is not real.
Okay.
Yeah, it's a prototype.
Mm-hmm.
Right. I'm not sure that having a general function as the second argument really addresses the need for tags, and I just want to voice that if we do have tags, which we probably should, we should not repeat the mistake of throw and catch, that there isn't a thing that will catch all of them. Right? One arg throw and catch are fundamentally orthogonal to two args.
Right. I mean, let me ask this question.
So there are some other things too that are very old, like check and so on. Isn't there like a whole check family, like a guard family? Look,
I think there's only check and check abort. Yeah, I think there's check and check abort.
It's a whole family. No, okay. There's not.
Also mentioned check is fundamentally broken because it runs the entire computation and only does the thing with check after it's done if the message happened to show up. So it doesn't actually abort anything.
We have a bunch of stuff in the function repository that's related to this as well.
Yeah, I was going to say, this is the ultimate sign that you sort of have trouble with your function when there are, I think, not one, two, I think there are 3 different versions of check in the function repository that are like the check, and if it fails, throw immediately instead of waiting to finish.
Yeah. Right, and check all isn't documented. I mean, it's
I've never seen it before.
it basically can consume all all sorts of aborts, not just sort of messages.
So it's check and it's check abort together.
And more.
Oh.
Yeah, those check return and check match are in the function repository. We also have throw failure and catch failure, which work as a pair to do a very similar thing.
And fail on message, which is similar to check, but it stops on the first message.
And and Christopher's absolutely right that this is a sign that what we have built in is lacking.
Right. So let's talk about these tags.
So Christopher, have you sort of digested what these things are trying to do in the function repository? Because it could be that they are onto some, piece of it too.
Yeah. I mean, I hadn't heard of the row failure and catch failure, so I should look at those. I mean, I've looked at, for example, the different things for dealing with messages and so on.
Okay.
Yeah.
I mean, the function repository is all top level stuff, so it's
it doesn't matter because
it's probably all built on catch and throw. Yeah,
but there's still an indication. I think that their example should show why they wrote it, right? Presumably.
Yeah.
And that's their sort of use case, basically.
Yeah, absolutely. Yep.
Okay, so let's talk about tags for a minute, because as you're writing this code and you write a confirm and an enclose or whatever the thing is going to be called, a guard and a contain, I'm putting this enclose to catch this collection of guards, right? You know that at the time when you're, writing a when you're writing your code, but that's not visible in the actual thing.
Isn't there something you need to? I was thinking if I'm going to write a recovery mechanism, contain something. What do I know? What do I get?
Sorry, say that again, Roger. What were you?
When it sort of throws, it's got to throw some information, or I have no recourse to kind of recover. Do I know?
That's why it's throwing a failure object that has a bunch of information inside it. It's not clear.
There it is. It's all baked in there.
Yeah. The only thing is, so it's sort of complicated though, because there's some guard test where it's kind of obvious what it should. I mean, so all guards presumably in part of the package that they throw should contain the expression, the held form of the expression that's inside of them, probably. But then there are other questions like, for example, if it's a guard test, there's other obvious stuff that you might show. But if it's like a message, then there isn't as much. You can't, like if it's a guard test, you can. Well, yeah, I don't know. I mean, I think that there's some, depending on the type of guard, there might be different information that you have to throw. But
in general, there will be some association inside the failure object that you could unpack, including the failure object should say what type of guard failure caused that to be propagated up.
Yes.
And I mean, in principle, you can unpack it and see what happened. But here's the question that I'm asking. That you're writing a piece of code, you write a confirm, you write an enclose. You know when you're writing that code that the confirm and the enclose are supposed to be paired, right? Now, you could invent some arbitrary weird tag.
Are those just new names for what we're talking about? Or?
Yes, sorry. Those are two alternative names. I don't know which one is better, but I don't know, Christopher and I talked a little bit about names, but if people have ideas for names, that would be, I mean, we've got a long list of possible things. And there's a goal to have the name for something like guard be comparatively short, so that like echo, you can, the typical piece of code, right? When this is implemented, the typical piece of code that you'll see in the function repository will start enclose, blah, 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 blah. And it'll be all sorts of little confirms inside it. And so those names have to be things that aren't too weird. You see what I'm saying? Because a lot of code, sort of reinforcing code will consist in spraying these names in all sorts of places. So the question, I mean,
I'm wondering sort of how this makes code cleaner. How do we do it today? We basically do error checking locally. You do a step, and then you sort of inspect and do something. Then you decide to move on.
rather procedurally usually. That's one of the
Yes,
problems.
pretty much.
Right. So the goal here is, confirm the step you just took. If something went wrong, this is how you enclose that. This is the enclosure that you're being thrown to. But again, let's ask people here, because this is why we wanted this collection of people. There are patterns for error checking that have been developed, many different ones. What do people have to say about how they do it? I mean, is it in fact correct? I mean, I think Christopher wanted to actually look at examples of error checking code, and I don't know whether you've done that, Christopher, already.
Yeah, I mean,
how people do this.
Well, I typically, I'll just speak for myself. This is Rob. I typically use throw and catch, and always when our code and our, in system code, I always use a tag.
And is the tag like a UUID or what is it?
It's a string. I just use a string. So for like optimization, we have an optimization exception that we use. It's just something not to interfere with anything a user might do.
Right. I mean, although in principle, right? I mean, if a user had written throw of optimization exception or something like that, it would conflict. It's just unlikely that they would do that.
Yes, it's unlikely they would do that.
So I think we have to take as an axiom, it's probably got to be UUIDs, and we just have to take it as
no. Well, no. So the thing is, speaking from the visualization code, there's one tag that's used, sort of globally throughout all the visualization code. And so, I mean, because you have the catch, which is, wrapped around at a very high level. And if it triggers the catch, then, bar chart or whatever is going to return unevaluated. But all the individual little utility functions that are shared across bar chart and pie chart and list plot and whatever all have the ability to do the throw. And so it's a very general tag, which I suppose it could still be a UUID, but
then the code becomes impossible to read, and it's 40 digits long.
Right. And I'll mention,
and there's no guarantee that UUIDs are unique either. It's just unlikely that they will clash, right? So,
yeah, and we do the same thing in optimization as Brett described. We have bunches of little throw functions that can throw the same thing, and then we have catches at different levels depending on what you actually want to do.
And so when you unroll, after you catch, what do you typically do? First of all, how much of the payload do you inspect when you catch, and then what do you typically do to recover?
Almost nothing. I mean, most of the time, if it gets to the catch is at a high enough level that it's essentially you gave bar chart bad enough input or option settings or something that all we can do is return unevaluated. The other thing that it might do in a few places is fall back to some default value. And again, in which case you aren't looking at the payload at all. You're just saying, this didn't work. I'm going to fall back to something that I know does work.
My structure is slightly different. So what I do, I have several different tags. This helps me in keeping track of modularity and what depends on what. And then the other thing I always do systematically is that right before each throw, there is always a message explaining why we are stopping there. And what I throw is always $failed. And then functions that know this function I'm calling could return $failed, they will check whether this function returns $failed.
So is what you're saying that if you have some big function that's like the user visible function, instead of just having one catch basically at the top of that, you have catches that are lower down, and then if your bigger function calls the smaller function and the smaller function return $failed, then it will handle that failure at multiple levels. Is that kind of what you're saying?
Yes, because in that way I can use my own functions, right?
Yeah, yes. I mean, I am sort of take it even a step further than Jose. I never have non-local throws and catches. All of my throws are lexically within their catch. Because I've seen one too many Java stack trace, and so I don't believe in non-local throws and catches.
There's also other code that we have, like our symbolic code, where they are always polyalgorithmic, and it's frequent that a solver actually fails, and that's not a dramatic thing. You can't often predict beforehand whether it's going to succeed or fail. So it's sort of built into its mechanism that it will fail. It will try something and fail, and that's just how it operates. And obviously, you don't fail the whole big function because one local out of 100 solvers fail. You
right.
keep.
Well, we have that numerical computation as well. If some method fails, it doesn't mean it's completely hopeless. So you may want to go on and try. In fact, I just mentioned as a part of this discussion that in optimization, we introduced sort of an intermediate thing, which I called it's not a system symbol, but it's an optimization symbol called partial success, and that's when the numerical method gets a solution, but it's not really to the accuracy or precision that was requested by the user.
That's interesting.
So I mean, just one point to make maybe. So a few things. So the first thing is, there's a question about, how far out do you put the enclose or contain or whatever we're calling it right now. So I mean, I think for one thing, I think that in general, the general pattern that you're doing, you're not necessarily throwing all the way to the top, just as you don't with throw and catch, right? Presumably, this is basically just it's multi-level error propagation, but where the number of levels could be any number, right? So you can propagate different depths. Then the other thing is that, right, I mean, there's the question of, I mean, I think there's sort of a like good practice question about where do you put the contain or the catch, right? Like, I mean, I was talking to someone about this the other day, we were sort of, right, like I think I was talking to Connor about this, about how, maybe a more puritanical version of this would be something that did something like return, where it forces it to be in the same function. I mean, return is a crazy symbol, so it shouldn't be used, but, right. So in principle, you might say that good practice would be that you always have, the contain lexically around the confirm and so on. But
this raises the question of dynamic versus lexical. That is, we could, and this relates also to the tags question. There is a version of this that could be, I mean, I don't know exactly how it would work, but one can imagine a lexical version. The statement that, or maybe one couldn't, I don't know. I mean, that will be, within one function, it could be lexical.
Well, but then the thing is that, like, I mean, maybe I don't actually know what return does if you don't run it in a function, but so maybe it already does this. But I feel like the behavior shouldn't be that different depending on whether you put it in a function versus whether you put it in some random piece of code, right? Like it especially because you might just be running it in code where you're not writing any functions, right? If you're just running
sure,
you're just running something in a notebook interactively, you don't want to have to package things up in functions in order to tell it.
No, but the question is it lexical? If it was lexical, there would be no issue with tags, I claim. Maybe I'm wrong, but if it's lexical, then, I mean, it's not as powerful as the dynamic version, because in the dynamic version, something deep inside some other piece of code might generate a throw, might generate a confirm failure, and then propagate up. If it's lexical, it's much safer because you can explicitly see, my question is, people's use of these constructs, are they in fact using them lexically, or are they using them in some much deeper function that is?
I've definitely found the need to propagate things upwards. I just made a resource function recently called nested catch, which sort of addresses that issue.
What does it do?
It's like catch, but it'll propagate the throw upwards to the outermost enclosing nested catch. So if you're writing, package functions and you have an error in one of your private functions, you can throw that error all the way to the top of your package and still have your catches enclosing your stuff lexically, so you can use your private functions without worrying about uncaught throws and stuff like that.
See, to me, I mean, I think this area is fairly important, and having multiple types of functions is not completely crazy, it seems to me. I mean, just like we have module and we have block, which do lexical versus dynamic scoping, I could imagine that there is a lexical version of this, which is much safer and much more what one would use in production code. And there is a dynamic version that is much more, is usually not what one would use in production code, but nevertheless, I mean, because in production code, if it was lexical and there was a good forwarding mechanism for enclosures, that might be a nice, robust way to do it, perhaps. I don't know.
Okay, so two questions. So the first question is, if it's lexical, so if it's lexical, then presumably, so if it's lexical, first of all, would you want to include the enclose, or would you just say, oh, it just goes to the top of the function or something like that?
No, you want to include the enclose because that's in a piece of code. I mean, maybe it's crazy to have it lexical. I don't understand the propagation of.
Right. So my catch is almost never. Right. I suppose I might return, or if for some reason they need to return unevaluated, right, then I'm going to have res/semi-res not equal $failed or something. Right?
By the way, that whole returning unevaluated, we have to get a better way of doing that. We had a mechanism in version 0.9, which was taken out at the last minute because it was semantically hard to define. But I really think we need a better, rather than these weird, idioms, we need a better way to just say return unevaluated. Did you think about that, Christopher, yet?
We talked about it a bit, but we haven't really. I don't think we had any real conclusions. I mean, there's also just the general problem, which we mentioned earlier, about detecting when things return unevaluated, right? And you can do things like, like was proposed earlier, you can just look at the head is what you expect it is, but it's kind of like there isn't, when a function returns unevaluated, it's sort of ambiguous what that means. Like whether that means, oh, I'm just a symbolic function and I'm happily returning unevaluated, or if it means I've horribly failed and my inputs are terrible and it's hopeless.
Right. A good example of the head failing is sparse array. I mean, that's not a good check for sparse array.
What do you mean?
Well, if you construct a sparse array with rules, it creates an object which has head sparse array as well, but it's completely different inside.
I see. It's a non-valid sparse array.
Yeah.
So anything that's its own constructor, essentially.
Right. Anything that's its own constructor, that cannot work for. I'll also mention that the lexical, I think, so one place where I've used throws, and this would actually be a very nice mechanism for, is in various frameworks we've put together, such as the structured array framework that Jose has used. We have a particular throw tag you can throw out to say, okay, I don't have an algorithm for this, so just go back to the normal thing. And you don't know where it's going to be caught. It's something that sort of a person writing code for this would do, and so the lexical would be completely inadequate for that. But this guard, non-lexically, could be really useful for that.
Right. There are a few comments on our live stream. I just want to mention them. There's a comment from Gecko State talking about fail-jure, apparently a library for Clojure. Christopher might be worth looking at. Anybody know about that here? There's comments about try. Let's see. Tichu is saying use null objects instead of control structures for error handling in Java. Java use finally to execute code regardless. Let's see. Various comments about Java APIs. Yeah.
There's a good comment from, well, I can't pronounce it, SWSH, about monads. So I mean, this is okay. So there's maybe just something we should mention quickly. There's another version of this which I think has uses, but different uses, which is basically the problem of single level error propagation. So that is basically the idiom, if missing q of hash, then hash, otherwise f of hash. right? So this is like really common. For example, if you're doing like data processing stuff and maybe you have a list with a bunch of data in it and some of them are missing and you want to run some function over it. And of course, if the value is missing, you just want to propagate the missing up one level. And if it's not missing, you want to apply the function. And of course, it can be more general than missing. It can be failure and stuff like that. But, right. I mean, this is a very common idiom. So this is another thing that should probably exist, although it should probably be some sort of headdress or something.
So is that what you've had guarded? Is that what your guarded does?
I think guarded is slightly different. Guarded here is kind of crazy. I think guarded basically, it just basically runs guard on all of the inputs, with the theory just being it's a headdress version. But I don't think it's that useful. I mean, the use of it would be functions that take pure functions. Like if you wanted to basically use guard on the inputs to, nest or something like that, then yeah.
But so the other thing is, I don't know what the right name for it is. We don't have any idea yet. But the basic idea is, if this has any argument that is missing, then it becomes missing. Otherwise, the thing would just return f of x, y, right? That's the other form. So that is a non-propagating. And I suspect there's something in between these two. That is, this is a one-level non-propagating,
single-level error propagation. It's
right.
One level, yeah.
Right. Whereas this is, there's two paradigms. There's the single level, and then there's the throw-catch type paradigm. Well, there's actually two kinds of throw-catch. There's lexical throw-catch and dynamic throw-catch. This is, in some sense, a lexical one-level propagation. Is that true?
I would argue it's not lexical, but I think that, right.
And I'm not even sure it's one level, right?
Why is that?
Right, because this, I'm saying it may be fewer than one levels, right? I don't see how this, aborts the rest of the evaluation.
It doesn't.
It doesn't. So the point is, right, so if it aborted the whole evaluation, that would be like many levels, because this could be very deep and it's
no. Right. So in sort of the idiom that I was talking about, right? I have an outer catch, and then at various points, I will throw failure if something goes wrong, right? That to me is one level. How do I accomplish this? How do I accomplish that with maybe? I don't see. Okay. This looks like less than one level.
I think we're using different terminology. So the point about this is like a monad. So this is like the maybe monad in Haskell, for example.
Okay, I don't know what a monad is.
Okay, that's fine. Basically, it's just what this is doing. Okay, when I'm saying one level, what I mean is that an error occurred at level 3 levels deep in your code. And it's been propagated up, so now it's at 2 levels deep, if that makes any sense, right? So the point is that instead of the error, happening deep in your code and going all the way up to the top, that's the use for sort of guard and contain. And there's a separate use case, there's a separate problem that a separate function should solve, which is the single level error propagation problem, which is more if, like, let's say I have data with missing in it and I want to map some function over it, and my function can't take missing, right? So these are like two distinct problems.
So this is essentially, one part of this is the handling of missing in lots of functions is quite problematic. Something like mean does not handle missing in any very sensible way. But this is dealing with an upstream question, which is I've got some data. Look, if I say data 2, 3, 4, 5, missing 6, 7, and I square it, okay, I get a totally stupid result, right? Whereas if what I did here instead, and I'm afraid it's not very elegant, but if I said, maybe hash squared of this
slash at that.
Oh yeah, right. Slash at. Wait, is it the maybe?
We could talk about having level specs or something, but I think this is the slash at is maybe the.
Okay, so then slash at this, then the result will not be missing squared. It will just be missing in that position.
Right. It'll be 4, 9, 16, 25, missing 36, 49, etc.
Does that make sense to people? Let's ask a couple of questions.
Sorry, I was muted. I was asking a question of, is that the result because the maybe always returns a missing, or because it turns into identity if something goes wrong?
I think it turns into identity, because I think that there might be useful information in the missing.
Like a failure object might have an actual packaging inside it. Well, a missing could have packaging inside it.
Right. I mean, but that's another difference between these, by the way, is that I think for the confirm and close version, you'd want to package it in a failure object by default. But because basically, let's say you have some confirm test and it's testing for something weird. Like, let's say you do a URL request and you're testing if the status code is what you expected, right? Then if that gets propagated up as a HTTP request object, then this is like a weird thing to be directly propagated up. I think a failure is easier to handle at higher levels, and if you want to, you can unpack it. But in this case, if it's just a single level, you just want to move the failure up, up a level.
Let's do a couple of things here. First of all, maybe Christopher or others could review stuff in other languages and other ideas, and then let's talk some more about.
That was really my question too. Like some other sort of more recent language designs of how they tackle it, like Julia, for instance, or Python. I guess is not that modern, but they certainly have a variety of code going in there.
Christopher, Connor, anybody want to talk about this?
All right, so I can say a few things. I don't know much about Julia, but I would say that there are in most of the modern languages that I've seen that have sort of tried to seriously do error handling. So, like for example, in Swift or Rust, which I think both care a lot about this, the basic strategy is they have two constructs. So in Rust or in Swift, there are these things called optionals, which is basically if I have an int, if I have a type int, I can also have a thing that's of type int ? Which is an optional version of int, where it can either have a value like 2 or it can be nil. And then the idea is you have functions which are basically equivalent to this maybe thing. It's a sort of a monad operator idea. And I have a function where if I have a function, let's say I have a function f and it takes an int, then I can make a version of that function. I think you just write f ? And that will turn f ? is a function that takes an int ? and returns a whatever f returned ? and basically does what maybe does here. So if the input was nil, it returns nil. If it wasn't nil, it returns f of that value. And then the other type of error handling they have, which I think is kind of not as elegant, but it's sort of analogous to what this enclose and confirm does, is they have like try and I think it's try and accept or try and catch, and that's sort of right. You have things that throw exceptions, and it goes all the way up to the catch, which is some catch block.
But it's like the long distance jumps.
Right. That's the long distance jump version, and then the optionals are the short distance. They're like maybe here.
Mm.
Yeah. And I mean, Rust does something pretty similar. Like they have this. They have Connor can probably talk more about this, but they have like these result objects and these I think called option objects, which are analogous to the pretty much analogous to optionals in Swift. Yeah.
Connor, do you want to say something about that?
And then in addition to that, the question, I mean, Rust also has a question mark operator, and it, you apply it at the end of an expression. So you do, expr question mark, and if the result, is a failure or, a missing like thing, then it gets propagated and returned from the current function. So that's.
And how do these languages handle what we've been discussing as tags for confirm and enclose?
Well, I mean, in the case of, of course, for the case of like optionals or option in Rust, these are single level, so you don't have to worry about that. For in the case of like the question mark Connor was just talking about, I'm pretty sure question mark, you can only write question mark inside of a function where the whole function returns an option type.
Correct.
Right. So it basically, if the question fails, it just calls return. Yeah. And it goes all the way to the top of the function. And then in contrast with Swift, you have to have these, I think they're called catch blocks, where it's, you write catch, open brace, some code, close brace. And then after the catch, you write accept, and then you write the name of the exception or something like that. and then under there you write the code that you run if the exception is, if the exception is triggered, which is almost exactly analogous actually to the way that confirm and enclose is here.
So Sandra is commenting in Python, there's assert, raise, and then try, except, else, and finally. What is the finally? What is the notion of cleanup for what we're talking about here? In other words, if you had constructed something, then you hit a confirm, the confirm fails, but you've got some open file or something. Or do we not? What kind of cleanup? And there's a question to everybody here about, cleanup. I mean, there are fairly few long distance side effects. The main ones I think have to do with files. What do we, how do we do long distance cleanup? How do people handle that in existing code? Is it mostly stateless?
I usually use with local settings in the internal context for that. We have a pretty good mechanism for handling that type of stuff.
What does that do?
It basically, the last argument of it, like if you throw or abort.
Well, the first, and it takes 3 arguments and evaluates them in order, and the first and last are uninterruptible.
Oh, right.
So the first is basically saying, I'm going to open a stream or something like that. And the last is I'm going to close the stream. And in the middle, even if something goes wrong, it'll still close the stream.
Yeah, yep. So if you throw from expert there, it will finish final before actually sending that throw. So you can clean up your streams or whatever.
We should have this function as a user level function. Why on earth don't we? How long have we
had check abort too?
How long have we had this function with local settings? I vaguely remember that function from a very, very long time ago. Is am I right?
There was some bug that was preventing us. But it's been here for at least as long as I've been with the company. So that's a decade.
Great.
And there was some bug that we wanted to fix before we documented it. I don't know / remember. Jeremy might, who I don't think is in this meeting, might remember the details. I don't know what the status of that is.
But this seems like a highly useful construct.
And right, and possibly with a better name than with local settings.
Much better. We need a better name, right? But I mean, is there a value? Is that the right construct for this? That this is always a block? I mean, it's some kind of block, basically. Is that
so? I mean, there's to reference another weirder language. So in Go, there was in there, Go has very little like actual error handling constructs because they sort of want to be minimalist. But there was a proposal for Go 2 about how to do error handling in situations like this. And they have a similar but slightly weirder concept, which is that throughout your code, you can sort of write a line that basically says, run this at the end. And if the function fails, then it will go up. It'll go up and run those lines in reverse, if that makes sense. So basically, if you write open this file, and at the end close it, and so on, or like if
you're saying basically
fails,
you're sewing final. You're sewing something to do in the final state, and when does that sew go out of context, so to speak? When that block has been finished, then the sew finals that were in that block are no longer valid. Is that the idea?
I guess so. I'm not sure what you mean by sew final. I mean,
well, what I mean is you're just throwing things out there, and you're saying if this block were to not end itself naturally, then go back and reap all the things that were sewn and evaluate them. Is that right?
Right. Well, kind of, but in reverse order. Which I guess, by the way, this is I'm realizing that this is very nicely done with local settings, because if you have nested with local settings, presumably it runs them from the inner one to the outer one.
Yes.
And so it sort of mimics this reverse order concept.
Okay. So let's talk about other people's experience with error handling. And I think the other thing we've talked about a little bit is messages and how devastating a message is, and trying to bucket different categories of errors into, was this just a weak error like your this particular numerical method didn't converge to, and I've long been advocating the idea that we have messages that are off by default, that represent things you might not, that you might consider an error, although you might consider them just par for the course. Like that, that logarithm turned out to make a complex number or something. You might consider that an error, or you might consider that just par for the course. Do you want to, Christopher, do you want to comment on this question about bucketing error messages?
I mean, I'm not sure how much there's to say. I mean, it's just that the thing is, in existing code, messages can mean like vastly different things, or like the fact that some message was thrown doesn't necessarily tell you much, because like in the case of part, right? When part throws a message saying the index is out of range, this is like a catastrophic failure, right? And the whole function is toast. But when integrate throws a message, half the time it's just a numerical thing, and you don't really care, and it's gonna return a reasonable result anyway. And so, right, I mean, this is the problem with some functions like guard message and stuff like that, is that you might think that messages tell you if it's failed, but messages actually, the fact that some message is thrown doesn't actually really tell you anything officially.
So I have a question.
Right, and I mean, right, and another problem is if it only triggers on messages that actually fire. If you somehow got into a state where general stop has been invoked, then it won't actually fire. And on the other hand, if it responds to all messages, even quieted ones, there's such an infinite number of messages that are off by default that you won't be able to evaluate anything.
Right.
So,
but the question is, is there a meaningful way to bucket messages? So on our live stream, Brian is saying, differentiate between info, warning, error, and fatal. I think that's really challenging for us, but I don't know whether those are, that's a message categories. Do we have a meaningful, it turns out we actually have some documentation that does distinguish message types. Didn't we find that recently?
It's like message groups or something like that.
Oh yeah. I've mentioned these before in these meetings, right? Maxine for V6, I think, but they're sort of functional areas. They're not severity levels.
Okay. Yeah. Are they useful? Does anybody use them?
Certainly the packing group is used a lot on and off of packing.
What do you mean?
I see.
What's the
on packing? This is it's a group of messages.
That group. Okay, I thought you meant the group of people.
No.
I have a comment here on messages. Something that we have imposed on us is the fact that when a function emits a message, it has to have the right head. It has to come from that function. And when you have nested functions, sometimes it's quite difficult to keep track of that. So we go into considerable effort to keep track of the right head to emit the message. And I wonder how important is that?
Well, it's
so what you mean is,
go ahead.
Well, I'm just going to clarify. So what you mean is, like, let's say you have some internal function, in like geographics or something, that's called by a whole bunch of different top level functions. And the point is but that inner function might throw a message, and you want it so that the head on that message matches the top level function that the user called, as opposed to the tiny internal one.
Exactly.
Right. Or even a more dramatic example. Suppose you call solve, which loves to issue messages. Is it okay to see the solve message? And certainly QA complains if Itai's wonderful function issues a solve message, so I need to sort of catch that and then rethrow it.
Vex optimization stuff, which is relatively new, is we trap the messages and then attach the outer solver head to all the messages that seem appropriate.
Because this has an unfortunate consequence, which is that we have a limit in the number of messages per function. And so because different functions will start emitting different messages, we have this spew of messages.
Yeah.
And so if we had some sort of global limit, or the messages were not associated to heads, then we would have just a few messages and that's all. You already have the information that something is going wrong.
So by the way, I mean, as a general point about this, arguably what you'd like to do is, instead of having some random function that you're calling deep in your code, throw a message and then you sort of catch that and handle it and so on. What you might like to do is something like, what guard message kind of does, which is that you run guard message around the code that might throw a message, and then at the top, you have an enclose that can then see, oh, a message was thrown. Here's the message. Let me deal with this and so on. Which it seems like Rob, it seemed like what you were saying was sort of similar to that. In the context optimization.
When does it happen? Right? Does the message get generated? If the function is going to take a minute to run, it makes a big difference whether it is generated. Well, I guess if the guard fails, it's propagating to the enclose anyway, so there is no time delay.
Yeah, I mean, it shouldn't do what check does, which is finish the evaluation before running.
That's just wrong. Right. Yeah. But this question, I mean, the whole point about attaching symbol names to messages is that is one way in which messages become computable. The names of the messages are absolutely not computable. But the head of the function which generated the message, you might think you could compute with. Does anybody compute with that or not?
Well, did you mean the whole message name? Like, do you mean head, colon, etc.? Or do you mean
something like log, : arg count, or something like this, which is the fact that there is a meaningful computable thing there. I'm asking the question, does anybody in their code, as they generate messages somewhere, does anybody look at that head to make a decision about what to do with the message? Or does nobody care? And is this thing,
that's what check does, but people do that via check.
In what?
Right, that's the place. That's the place where you name a message that you want to catch.
No, I understand, but then you're naming the whole message. You're not just naming the head, are you?
No, but you're naming the whole message name. But that's one place where it's sort of a computable use of a message head, of a message name.
Right, I understand that. But what I'm asking is the fact that that first thing is the name of a function, and you could potentially look for that function. Is that relevant, or is the whole thing here? Could it be message ID number such and such, and that would be good enough? I mean, it's obviously
or alternatively just argct as opposed to log : argct. Is that what you're saying?
Well,
yes, I'm asking.
The head is incredibly useful. I mean, so when you're debugging, if I'm debugging a case of Wolfram code, I look for basically the first message that comes out in the head, and that gives me an idea of where it's happening.
Well, I agree.
If you didn't know the head of the function where it happened, if you just, instead of like a transpose message, you just had some random message, you wouldn't have any idea that was happening in transpose. And how could you even start to look?
So basically what you're saying is that it's a good way of characterizing, you have a big piece of code and there might be 8 transposes in your code.
Right.
But just knowing that it's transpose as opposed to linear solve or something is a kind of a trick for somewhat localizing where the message came from.
Right. So it's not computable except within my head, basically.
Right.
That's what I'm trying to say.
Right. I mean, the stack trace would give you a little bit more information about where the message, where in your code the message came from. I mean,
right.
And the debugger, when it was in operation, so to speak, would potentially actually display for you. And I don't know whether, does Brenton have any comments on this and the whole question about connecting messages to code and so on?
No, I don't have anything. I mean, if there were patterns to check, I can definitely, the system I have can definitely check for these patterns of usage and, but
no, I guess my question is that, the best case would be you click on a message. If I generate a message somewhere here, if I say, let's say
1/0.
Right. Well, certainly the link depends on the head, right?
Which link?
The click on the little
documentation link.
Yeah. Yeah. Right. So if there's a dedicated message page, it'll go to the message page. But if it doesn't, it will go to the head.
Yeah, I think that the head is important because half the time, I don't know, half the time I don't even look at the message. I just see, oh, it's a problem with, part. I know what the problem is.
Right.
But
okay, but so the question.
yeah. Go ahead.
No, I mean the one. I mean the names of messages. By the way, let's talk a little bit about that. You know, the names of messages were intended to be short but not completely incomprehensible back in version 1. I suspect that if we plotted the length of the names of messages over time, they will have gotten progressively longer. Does anybody want to comment on that?
There are some very long message names these days.
And
But I mean, you can see that they're not even displayed in the latest,
well, I know we've
front
chosen
end.
not to display the message names because they were kind of a mess.
I mean, it's only on tooltip, right?
Right, which is kind of frustrating to me, but
well, no, you get.
I mean, I think the
message name here.
Yes,
I mean,
but I still need. Okay, yes, but now I need to move my hand from the keyboard to the mouse or trackpad and hover and wait in order to see something that used to be just right there.
I mean, I think in principle the problem is that, I mean, there are a lot of functions that have really ugly message names.
Right.
Or
well,
ugly
there's
or
a question
long.
of right. There's a question: should we curate the message names in some way, and if so, what would they be curated to? Because the problem, one of the worst problems of the message name, is you have a very meaningful message name and the meaning is wrong. That is, the message says, ill-conditioned system of equations. But actually, the reason for the numerical error was something completely different. And you're off being confused.
I mean, that seems like that's a more I mean, do you mean where the message name says that, but then the message content explains the correct thing? Or do you mean where the whole message is just straight up wrong?
No, where the message, I mean, this is the famous thing about, the comments in code are more buggy than the code, so to speak. And they get people confused. Because knowing what went wrong, I mean, our messages, back from the very beginning, the messages are supposed to always just say what happened. They're not supposed to offer a theory. But increasingly, our messages do offer a theory. So it might say, file not found or something. Or it might say, no, what might it say? It might say, somebody is making a bunch of background noise there.
No, I mean, they're trying to offer, some of them are starting to offer advice. The following went wrong. Try these, try this.
I know, right.
Try
And there's a question about how that should work and whether that should be segmented off from the just say what happened. Because the problem with offering advice is that it might be completely wrong. That is the thing. Can somebody give an example of this? There's got to be an obvious example here.
Rob, you should be able to give an example.
Well, yeah, an example. It's one I've seen you comment on is some of the messages that come out of the compiler. If you give a function it doesn't recognize it, it gives a bunch of suggestions, which are almost always wrong.
Well, I was thinking more of the one from
that message is stupid, Stephen. So that's
right. Well, Rob, I was thinking more of something like in desolve or convex optimization, where at least some fraction of the time the message is right. Try method blah, or try, where it at least some fraction of the time actually does tell you something useful.
Well, that's fine, but the thing that concerns me is the case where, what we know is that things went way out of control somewhere inside the code. But we think that the chances are that happened because of whatever. Mm-hmm. And we just say that. But it turns out in reality, it happened because of something else. And the person finds it much harder to debug because they were just led off track. Now, hopefully Brenton's stuff with code assistance will give one a better way to handle things like that. Where you can
I think for both standards sort of tell what happened and give advice. There's often sort of extra state that needs to set up in computation just to sort of diagnose and tell what happened, in a reasonable way back to the user. And likewise for advice, there's additional state and something that needs to be set up in order to kind of arrive at that.
Well, an example of an advisory thing that Itai was looking for is we did this a little while ago, that in our optimization solvers now, if somebody gives if you wind up with a constraint that's just strictly true, it gives a warning message, because so often it was the case that you put in a constraint wrong, or you used an equal or something like that instead of an actual constraint. And it, if it's true, of course it's true, but it's not typically what the user intended.
Okay, so I think that's an incorrectly done thing. So I think that should go through Brenton's code assistant stuff.
Mhm.
Should lexically look at what the person typed in. And in other words, if it turned out somewhere inside the code that the thing turned into true, but it was not obviously and trivially true because of something that they typed a single equal instead of double equals or something.
Right.
I mean, and the single equals should turn red inside the optimization code as it does inside solve.
Yes, no, that, I mean, having an extra parser pass or something for things like this that we'd actually have access to would be incredibly useful.
I think that's basically what Brenton is building.
Yeah.
Is elaborate. I mean, and we have to distinguish stuff that can be done at code construction time versus stuff that can only be done at runtime. And what Brenton is building is an elaborate system for dealing with code construction time. Is that a fair characterization, Brenton?
Yeah, I mean, traditionally we say static analysis and stuff like that, but yeah, the lexical, I mean, yes, what you're saying is true.
Right.
Yeah.
There's a different issue, which, I mean, when we're talking about messages, that's all runtime. And
correct.
But I want to come back to someone's asking here about where is our message documentation these days? I was looking for it recently and I couldn't find it. Where is it?
You have to generate the message and link it and follow the link.
So it's not browsable. Is that what you're saying?
Basically.
Why isn't it? Why isn't there a big? Why isn't there
ask Brian or somebody who's responsible for documentation.
Why does that not go to the message?
Oh, because there is no message page for it. So do something like the following. You'd set the $, what is it? $, notebook inline storage limit to 0.
That's probably going to break my whole session, but yeah, okay.
No, it won't. And now do like sparse array of 1, 2, 3. Okay, now copy that output and evaluate it in an input cell.
This is pretty elaborate, okay.
And, why is there... That should take you to an actual message page.
My gosh, that was really elaborate to get there.
Well, that's because I've made it so hard to encounter these things.
No, but the question...
Oh, I see, to get to the message.
Right, so we used to have a whole booklet that you could get with all the messages in it. How does somebody get to this?
Yeah, can you go to like just ref/message or something? Or I mean,
it's ref/message/head/ Yeah. Oh no, there's nothing browsable. The documentation center is not set up to be a browser. It's set up to be search and follow linkable.
This is not obviously correct. I mean, we should probably, make those messages. I mean, I think the reason we probably made it so hard to get to is, and only get to on demand, so to speak, is because we never finished. I mean, we did a complete pass of documenting all messages back when 20 years ago or something
in V6, so more like 15 years. But
yeah, we did an update then in V6 with Withoff,
and then it was so. And I mean, it's only in the last couple of years after Oliver and I complained enough that DocuTools was updated to make it easy to edit these things again. Because it used to be you had to go spelunking to edit these pages. At least now there's dedicated buttons for it on the palette, but it still leaves something to be desired.
Concerned me a lot with these messages, and the message documentation was that it's so hard to not mislead people with the message documentation. Oh, you got this message. Oh, probably what was going on was X. Now,
but the documentation that took time for that was to construct an example that issued the message.
Right. Yeah, that's another issue. Yeah, right. That's another issue. But I mean, in a sense, we've been very successful with spell checking and completion and so on, where it's like there is stuff there that is totally irrelevant to you. It's spell checking to the wrong word, but you don't care. So long as one of the things that's said is what's really relevant to you, you're good. And perhaps there's a way, perhaps it was a misthinking about message documentation that because there were 5 things that were irrelevant, the fact that there was a 6th one that's incredibly relevant to you might be sufficient, if that makes sense. In other words, my negativity about putting in more message documentation because I thought it was would mislead is like burying the correct leading in that. Okay, so I want to come back again to, I mean, the various comments here about expert systems for messages will be great, and I agree that there are probably some machine learning-ish things that we might be able to do with patterns of messages, and it probably will be worth investigating. I don't really know what. I mean, I'm not sure whether we have a good training set for that. But I mean, does anybody want to? Okay, that idea, and then I want to talk about message buckets, and then we should wrap up soon. Anybody want to comment on machine learning for message spews? And for example, back in version 1, our strategy for stopping messages was purely when you've got 3 of the same thing, stop. But perhaps we can be more sophisticated than that. Anybody want to comment on that? I mean, personally, I don't really mind. The message spew is finite because it does, it has to have newly named messages to keep spewing. And I don't mind the fact that if something went horribly wrong, that I see, a page worth of messages.
Well, although it is sort of a, ideally you would catch, if you had, better error handling functions, maybe you would catch the error before it spins out of control and throws hundreds of messages. But yes.
Well, so
there are two. I mean, the two real downsides, which I don't think you encounter that often, but when you encounter them, it's really annoying. Is when the spew is so large and continuous that it really slows down.
Yes. But how can you get that? Because it will stop after 3 copies of the same message. How do you end up getting new ones? Unless you're doing a separate cell print or something like this. I don't even know what resets the counter, actually. How do you get infinite message spew? I know I've managed to get it. I know how I've got it. I've got it doing parallel computations. But how else?
Yeah, I don't think the counter. I think the counter is separate for every. Actually, I think it's even weirder that the counter is separate for every kernel because I've run only a few kernels and gotten more messages. But I think.
Well, that's a question whether it should be local to whether we should have a global counter somehow. But I mean, how else do you get giant message spew?
Echo or print.
Cascades.
But yeah.
Yeah, go ahead.
Yeah. I was going to say, right. So it can be if it's sufficiently, if it's sufficiently deeply nested, then right, when you go through enough functions in the stack with different messages that you can do that, right? And obviously, if you have a print statement in there, then
but print statements, the echoes and things like that. You asked for it,
right?
But I want to come back to this question about bucketing messages. And how we
I tried, we made an attempt before. I wanted to distinguish between warnings and errors.
Mm-hmm.
So there was like the super coarse bucketing, like 2 buckets.
I predict that it failed.
It did.
As evidenced by the fact that we aren't using it right now.
Yes, it did. It was just, it wasn't clear cut. And it might have could have persisted perhaps, but
no, but it's not going to work. We know it's not going to work because somebody's error is somebody else's correct behavior. Take log of -2. Is it an error that it gives a complex number, or is that correct behavior? To somebody.
Well, clearly that's correct behavior. It may not be what the user wants, but it's correct behavior.
Okay, what do you mean by correct? I mean, there are things where there are structural problems, like part running off the end of a list.
Which I find to be, it shouldn't warn about that because we want symbolic vectors. And God damn it, it should be able to deal with that.
Well, okay, so Roger, that leads
and we created indexed just to get rid of part.
Yeah, I understand. But so an alternative there is, I want part to be generalized, but then there will be no part messages, and then people would not know that their code was broken.
Right, but we have this, we've had this tenuous thing. So sometimes when we've generalized the language, we've actually turned off messages. so that we can use some of those, constructs as symbolic kind of representations that the previously would generate messages, and we've turned some of them off.
I know. So the cost of that is less ability to detect when code is going out of control.
Exactly.
Right. And I think in the case of part, there's a good argument to be made that is too high a price.
Right. Well, so the point is that in a symbolic system, everything can in principle be returned. And so, the question is, but some things that we return we might say that's obviously wrong. But in principle, anything can be returned symbolically. I mean, it's reminiscent of, in a typeless system, you don't get to do type checking. And, but you can have an advisory thing that says this is probably wrong. But so my question would be.
I mean, the problem is, though, is that, like, I think, especially across different areas of functionality, it's very inconsistent what returns unevaluated and what fails in a different way, right? Because, for example, in lots of math code, or for example, in the geometry code, it's extremely common for things to return unevaluated, because it wants to do symbolic things. But if you're using, cloud functions or machine learning functions or something like that, then they almost never do it. And I think at some level, this is because most of the time when functions return unevaluated, they return unevaluated because they
hope for the future.
They either hope for the future, but even more generally, I mean, more practically, because they're obviously because they can tell by basically the pattern or a few levels down from the pattern that it will fail, as opposed to you ran a whole bunch of code and there was a specific failure in the middle of it, right?
Look, the reason for returning unevaluated back in in version 1 or something, the concept was if you ask for something that we don't know what to do, we don't know how you should interpret it, 0 to the 0, let's say, or whatever it is. I don't know what we do with that, but it returns unevaluated, but then the user in principle can assign their own value to it or can replace that with whatever they want to replace it with. So that's the theory. Question is, does that theory work?
So I found that there are obviously good cases where it works. You do a symbolic integral, it fails, you hit it with n, and the representation is still sitting there, so it works.
Mm-hmm.
You do an alternative, kind of evaluation. That works. But for many things, and I'm trying to remember now, but I think I've increasingly encountered it now over the years. It's like something comes back and there's no hope of doing anything with it. And then I wonder, what's the value of returning unevaluated then?
Like if or which, for example?
Well, I guess if you can use if like piecewise, right?
We treat basically if and which as piecewise in all the math code.
Right, but I mean it's true that so we don't need to do that.
Sure.
Yeah, I mean I think if
returning unevaluated is a really bad thing. That if we could remedy that, and similar case with which and switch statements, would help everyone that has ever written code incorrectly, Wolfram language code incorrect. What that line is right there, input 11, returning unevaluated.
This is a Brenton,
does not help anybody in 2020 at all. And it's wrong that this does this still.
Well, Brenton, if I might say so, your project should solve this.
No, this is still a runtime thing, though. This is not what I'm working on.
Okay, but so again, what would potentially solve this is a message that is off by default, potentially, but catchable.
No, but the problem is, okay. So for the first half of that statement, the problem is you don't know if you knew to turn on the message, then you know what the problem is, and
right. But so if we had a way of bucket catching certain categories of messages, you could do that without, in other words, if you want to, if you care, look, let's say that this was a level 2 warning message. Doesn't make any sense. We're not going to be able to define that, but let's imagine it is, or let's imagine this is a code lint type 7 message or something.
It wouldn't be lint, but yeah, because you can't tell it, like Brenton
said.
Well,
fair enough. You can't tell it at compile time, but I mean, so it's a I don't know, it's a a I don't know, some programming level something or other message, and then you say, okay, I want my code to be working in this kind of way, so I'm going to just guard against all of that class of messages.
Even though the thing is
right,
that's not the common case for this. The case
but,
for this is I have a piece of code and I'm running it, and I'm getting weird results. I don't know why, and the answer is because if is returning unevaluated, because that's a weird behavior that nobody expects, right? So one solution would be to have it throw a message, but again, the thing is there's a lot of existing code that might assume that it can be symbolic. But the point is that by the time that you're doing something like guard, or you're doing something like, changing the message priority level or something, or turning on messages, you already know it was wrong.
Okay, well, I've got a different suggestion. What if there was what if there was a thing called verbosely, for example, which you run a piece of code and you run it verbosely, and verbosely switches on lots of messages that were off by default.
So it's kind of like, -- pedantic or something with GCC.
Yeah. And I mean, that way, let's say there was a message off by default in if. You get a crazy result. You say, rerun my code verbosely. And then even these messages that would usually be off by default show up. Now, if we could bucket messages in a reasonable way, something like that might be super useful.
And how is that compared to progress monitoring? Because I think that a lot of things are very similar when you want to sort of say, kind of want to say what you're doing. When you say verbosely, I think of tracing in some way.
Well, fair enough. Yeah.
And it's sort of kind of explaining what it does.
Well, I agree. That would be an interesting wrapper as well. I mean, right now, what we're planning to do is to put in print temporary type things that show up if anything took more than a minute, let's say, or more than some amount of time. Mm-hmm. But what you're saying is to have to have something that's like monitor, but let's say monitored or something, which I guess is also a thing. But let's imagine that we could do that, and then monitored would mean always tell us what's going on. Do the best you can. Waste the time to start printing things on the screen to say what's going on.
Well, and do you mean like things like progress indicators, or do you mean?
Well, I mean literally that it's giving a big manifest of.
So a lot of progress indicators are somewhere in between. So there's the progress indicator where you just have a sort of a bar that fills. Wait this time, but the other things that go through stages and they have some text that says what's going on, and that's very much like messages in a way.
Yes, it is, except that they disappear. I mean, so another issue is messages that evaporate. Messages that evaporate by the time you've finished. That's just a stupid idea for some of these things. I mean, that's look, okay, so there's progress versus messages.
Right. And so sometimes progress has other things, like for instance, like kill this, it's taking too long.
Well, I understand.
Stop it, or give me the best you got so far.
But the main difference between progress and messages is progress is something you want to evaporate when the computation is finished, whereas messages you want to stay there.
Yes, I think that's a meaningful distinction, actually.
Right, but are there other such distinctions?
But we're starting to do experiments, for instance, for solvers to be able to use progress indicator.
I mean, but that's what we're trying to get this whole framework for doing progress monitoring.
Right.
But I want to come back because a bunch of people on our live stream have been talking about having different level distinctions in messages. And as we've been saying, we think this is really hard to do. So the question is, can we have a better idea? I don't think a linear ordering of severity of messages is going to work. So the question is, what would work? Is there a way? I mean, or is it the case that what you want is, for example, here's an example. You could imagine just various groups of messages, essentially tags for types of messages, where a given message might have 7 different tags. It might be, oh, it's a numerical analysis message. Oh, it's a message that is, not a fatal, never a fatal thing. Oh, it's a message that's associated with this class of functions. You could imagine tagging messages and just being able to, if we had an organized way of representing those tags, if we had how many types of tags is anybody going to remember? Maybe half a dozen, types of messages or types of tags.
Depends on how good the auto completion is.
if you can remember the beginning of it. But you're saying, I mean, you're imagining. So imagine we could bring up a page that just says, pick your tagging, right? You could put a thing that says, confirm message, guard message, whatever, and then the autocomplete for that second argument was a great big picker that's a great big thing that sort of says, what kind of messages are you interested in? Could we do that? In other words, we've got this soup of all these different messages. Is there a way to organize that so that people could pick them, reasonably? Because what we don't want is something where, you have to personally go, pick all the pieces of fruit to get all your messages that you want. There's got to be some way to say, I just want the messages in this particular bucket.
Right. By the time you can make 100 buckets, then you have a problem, right?
Oh, I know. That's why I'm saying half a dozen buckets I think we could deal with, but are there half a dozen meaningful buckets? Or is it like, for example, here's another way of thinking about it sort of cognitively. If any given person would only have to remember half a dozen buckets, but if you work on different areas of the system and different kinds of computations, like it doesn't worry me too much if the buckets that are relevant to somebody doing, I don't know, mathematical computation are a little different from the buckets relevant to somebody doing cloud sort of systems programming in the cloud type thing. Because those buckets might be different. I mean, there might be a bucket of messages that had to do with sort of, web failures and so on that would be completely different in character from the ones to do with numerical precision, failures. So my question is there a way to think about bucketing of messages? I mean, the traditional way this is done, I mean, look, I have lived through, I could tell all kinds of stories about earlier histories of computing where people tried to have severity levels, verbosity levels, ask the user type levels, all kinds of things, and they're all horrible. I mean, I've never seen that work. Has anybody ever seen that work? I mean, for compilers, it's much easier.
And even then, I would argue Microsoft, which is perhaps the biggest user of this approach, gets several of them wrong.
Well, is it just wrong, or is it like they're wrong for your particular piece of code at this particular time?
Well, right. Right. The problem is if they declare that something well, and maybe it's just a problem of they use the same number for what are perhaps to me conceptually two different warnings. But there are cases where what I consider to be the valid warning is I guess the level 3 one, but then the stupid one is the level 2 one, and there's no way to say, level 3 or lower. You can only say, level 2 or higher. So there's no way to activate the serious, what I consider to be the real one without also activating the stupid one.
Okay, so there are a number of comments on our live stream which I think are interesting. So there's a comment from API Dear, liking a debug message that will include code execution times. I mean, this idea of an echo timing thing is a way to start on that. Okay, now Ethan is saying you're conflating use cases. Good, I'm glad to hear this, because this is what I want, is to break these things apart. Simple monitoring versus detailed logging versus debugging versus benchmarking, etc. Okay, can we tease those things apart? I mean, it's like we have a distinction here between progress and messages. Progress evaporates, messages don't. That's a meaningful distinction. Now, when in progress we can have sort of logging. One could imagine instead of
I think progress is different from logging. Logging is a debugging operation, and you don't want things to evaporate then.
Okay, fair enough. So that's what I was calling verbosely here, is kind of a logging function. That's the notion there, I think. And the question then is,
well, I think it's not, at least the way that the example you used seems more like a generalized something went wrong, just give me all the information you have about progress and about errors.
Fair enough. Okay, so that, yeah, you're right. You're right. So this is, well, one could imagine, we could imagine something else, which is sort of evaluate logged or something. I don't know whether that's and one could also imagine that it doesn't just produce messages, but produces an actual computable log. Hence our function trace, which never has been useful. But again, I want to come back to this question of, if we are bucketing messages, we are not going to have a linear order, because I don't think that can work. But is there useful tagging that we can give, or are the tags too mushy as well? In other words, what we're trying to design is this is like, okay, there's programs which just compute things. There's proofs that explain why they computed things. There's kind of erroring and messaging, which again is sort of a little bit like proofs. It's kind of explaining why things happened, or it's giving commentary on something. It's hard enough to design the programming language, let alone to design the commenting language. And the question I guess I would have is, if we were designing a commenting language, what would we design? In other words, let's say we wanted to make a computable commenting language, a commenting language where the results of the commenting language could be fed to a machine, as opposed to just given to humans. What would it look like? As I say, that was the hope of Trace back in 1990 or something, and it failed utterly. It's way too complicated. Even pruned Trace was too complicated. It didn't give one. It gave one just too much micro detail and not the big picture. I mean, in a sense, a commenting language is about, I want some kind of, the highlights, the big picture, what happened, how do I represent that?
The closest thing I think we have to that is assert, which is it's a much smaller thing, but I think it's the closest thing we have to that.
Yes, well, right, but I mean that's a tiny thing. I mean, what I'm asking is, what people are asking for, and I really think it's an interesting thing. And Brenton was making a big case about if for that, is I want to know, again, what is the typical workflow? The typical workflow is you write a piece of code, you run it, it does the wrong thing. What do you do next? Right? If there was one thing you could do next, like just rerun it inside verbosely, and you would see all kinds of stuff, all kinds of commentary about what the code was doing, and all kinds of, oh, this is the thing that might be wrong kind of thing. That seems like it could be very useful. And in a sense, that's an example of a one bucket.
Obviously we have that. It's sort of that's debugging, where you trace in detail what it does. But that wouldn't be very useful for, you have to, that's for a person that wrote the program and is familiar with it. How can you make that useful and informative for someone that doesn't do it?
Okay, so
that's what we're studying for progress.
Right, but for me, this is very similar to the proofs problem.
I got it. I understand it. You made that connection.
Right. I mean, and the proofs problem we've never solved. That is, we don't know how to, in Wolfram Alpha, when we have step-by-step, for example, there we have a solution to explaining why something worked the way it worked.
But it's sort of humanly created.
It is humanly created, yes. It is created in a very templated kind of way.
Right.
Whereas our automated theorem prover, absolutely hopeless, right? No human understanding of the proof. So the question is there a way, and maybe it's templated, is there a way of human explaining what happened? Is there a way, to me, I keep on coming back to this, messages, sort of trigger happy messages that are off by default, seems to me.
So we've built quite a bit of this. What we've never figured out is a good mechanism how to publish them. And at this point, I think that part of a ref page, if you read far down in a ref page, you will sometimes see that there is a message that's off by default that you can turn on if you're interested. So for instance, for viz functions, that sample functions, they have a goal. They want a certain level of smoothness for the curve or the surface.
Mm-hmm.
And if it doesn't achieve that because you've given it resource, give a message, it couldn't achieve the ACK bend or whatever.
Right.
I can't remember them now. It was
called ACK bend. It's a very old message. Yes.
Yeah.
And I don't think anybody uses it because it's off by default and.
Right,
but that's
so
an example of something that's off by default, and
right.
you can get more information if you turn it on.
But so let's imagine that verbosely simply turned on every message. Then that curve that you've got, I mean, again, I don't know if that's right, but you could say, put in more messages. You might need to warn people about this. You might need to warn them that they're computing log of a negative number. Or you might say, no, nobody needs to be warned about that. And, ultimately, people could be warned about everything. You're subtracting numbers and you're getting 0, and then you're multiplying 0. But, for example, a classic example is 0 times x gives 0, right? That can lead to crazy stuff going on. But it would be completely nuts to have a message in general for that case. But on the other hand, you might want a message that's off by default for that case.
I think something very useful could be that once you get a message, there is a way to automatically go to the code that emits that message.
Well, I know. I was asking about that earlier.
Or turn off this message forever.
Well, we have a mechanism for that. We have a mechanism right there. Turn off this message. But I mean, this question about jumping to where the message happened in the code, that's not always well defined. That code might have not been, there may be no lexical version, there may be no static version of that code that ever existed. Brenton, do you have any comments about going to the source of the message in the actual code?
I mean, my parser would, do that 20 times before breakfast if we wired it up to the kernel. I mean, you're obviously we could, you could put a string into toExpression, and the messages that come out of that wouldn't have a source line and column information, and that's fine. But we're talking about the 99% of all kernel.
I know. So
have a source location. Yeah.
So at runtime, a message is generated. Are you capable of going into your abstract syntax tree or whatever it is and finding the code that generated that message?
Well, yeah. I mean, just in theory, wiring stuff up to the kernel. I mean, the kernel could do this now if you flip the right switches, so that when you read in a package, it remembers all of the source information. If you turn on the right state in the right debug mode,
I know, but
information is in the kernel somewhere.
Right, but that's the debugger which runs the code much slower, right?
Yeah, slower and more memory and everything.
Right, but so that's why what I'm saying is, if we could have something, a wrapper like verbosely or whatever it is, that is easy to use, that just says, look, I want to run this more carefully. I ran it, it did the wrong thing, let me run it more carefully.
Well, but the source has already been read in, presumably at that point, though. If you haven't, by the time I want to do that wrapping with verbosely now, you've already read in whatever package code.
Well, that's a question. I mean, that's an engineering question I don't know the answer to. I mean, when the debugger was built, it just has a completely different data structure, but maybe there is some kind of weak hashing sort of attached thing that isn't actually part of the main data structure that you could use to find that information.
I mean, yeah, if the information's there. Yeah.
No, I mean, at the time of reading in, you could, for example, let me give a crazy example. You could fork off something that asynchronously reads the thing with the tagging information and sticks that out there as a thing based on hashes that will say, if you ever need this, it's hanging out there.
I don't know. I mean, that seems like a lot of work for not a lot of. I mean, I don't know what asynchronously means, and I don't know what. I mean,
I'm just saying we can't slow down the reading of a package every single time for the 0.001% of times that people want to run it verbosely later.
Oh no, yeah. So it just comes along for the ride every single time. Yes, all packages. At some point in time in the future, when you read in a package, its source information will be available.
Yeah, but that's only
always.
okay if it's like only a 1% slowdown or something. It's not okay if it's a 20% slowdown.
Well, I'm saying with the, yeah, I mean, just hold on. You know, like the parsing technology that the kernel's using is, you know, older than the kernel itself. And I'm saying, I mean, it would require engineering, obviously, but we don't need a slowdown in reality, even
Okay.
with this you know, it's putting a little bit of TLC into the parsing technology would.
All right. Okay. Fine. So you're saying we can
this
speed it up so much that we don't care about the fact that we're slowing it down slightly for storing that extra information, but alpha, which work a little bit like that. But imagine that you could take a proof and automatically generate text from it that is an attempt to explain that proof. I mean, I think in the current state of technology that will be a total failure, but that's the kind of thing that we would like to have. I think. I mean, various people here are asking for. Let's see. A commenting language will create defined assumptions based on what occurs at runtime. Define so they don't cause further errors. Yeah, I mean, I think the calculus of errors is really complicated because, in a sense, you know, it's like saying, how do you validate a piece of code? Well, what's the code supposed to do? Well, the code says what the code is supposed to do. Oh, so then we need to rewrite the code in a different validation language to explain what the code is supposed to do. Or we give certain asserts for what the code is supposed to do. But so what's the way to think about, again, I'm Roger, or anybody, Christopher, anybody else, sort of a way to think about conceptually?
I think we empirically discovered that code is almost impossible to understand if you have no other information, unless it was written to be understandable.
Yeah.
So we have plenty of legacy code, you know, since we have many people that worked over the years. And some of them, it's just easier to throw away and start over than trying to even understand it.
Okay, but that's not solving this problem. I mean, this problem is user-written code. Okay, so, you know, we have several levels here. So first point
people usually augment their code. If they want to prove properties about their code or they want to tell other stories about it, I think you're basically going to have to mark up your code with more information. And one thing that you can mark it up with is like for proving things or invariants, for instance, properties that are going to hold.
But you see, in a sense, Christopher's idea here with the confirm and close, you know, guard contain, that is a form of markup for code.
It is.
And in a sense, it's very pragmatic markup. It's not markup that's just asserting things. It's saying what to do.
Mm-hmm.
And now, so one question would be, with that conceptual idea, is there, I mean, in a sense, that idea segues into the message markup idea. See, I don't know. There's got to be a way. We have information in these messages. We have information in messages that we are as yet unborn messages that haven't been created or are not being generated by default. We have sort of meta information about what the code is doing based on its message trace, so to speak. Its n-gram of messages is some information about what the code is doing, particularly if the code is doing the wrong thing. So the question is, how do we best use that? Right, we've got this sort of zoo of messages, because right now, you know, like for example, we use very little meta information about our code execution. So for example, you know, as code executes, the stack is getting bigger, smaller, whatever else. Realistically, nobody is writing code that is asking, you know, admire the behavior of the stack, conclude what's going on based on that. I mean, the beginning of
unless you're teaching your first programming class.
Well, right. I mean, and don't talk to me. I was just studying transfinite numbers and combinators and looking at you know, this question about the anyway, never mind. But you know, Brenton's project to do with, you know, using machine learning and other methods on code analysis is the static version of this. That is, given the code, understand your code statically and make suggestions about it. But what we're asking for here is a dynamic version.
So I think that static analysis, when you're not using super expensive theorem proving capabilities, has been immensely successful in practice.
Yeah. Well, I know, and I think what Brenton is going to unroll for us in the next version with essentially spell checking like things for code is going to be really, really useful. I mean, just like syntax coloring, just like function, auto completion, all those kinds of things. There's another thing like that. It has I think the plan is to have a little bit of machine learning in there for guessing. I don't know, maybe Brenton can say what some examples of that are. I predict this is going to be very, very useful. And the fact that it is heuristic is nobody's going to be bothered by that. I mean, worst case is it's making an auto suggestion that isn't the right suggestion, so just ignore it.
But there's a ton of other static analyzers that are basically lightweight theorem provers, but they're so lightweight that they scale. They don't bog down like theorem provers do.
Yeah.
And they still find a ton of practical things.
Well, I guess that's the future of Brenton's project, is to expand, perhaps through the compiler technology and other things, expand the level of analysis that we can do.
Undoubtedly, yeah.
Go ahead.
No, I mean, there's a big roadmap. Yeah.
So I will have to leave in just a couple of minutes, but, the closest thing to dynamic analysis that I'm aware of are things like the address sanitizer and the undefined behavior sanitizer. And they, first of all, they're super focused. They increase the compile times by sometimes an order of magnitude.
What are you talking about there? I just don't know what those are.
They're tools for C and C++ code. Okay. So the address sanitizer checks for all sorts of, use after free, mismatched things, and the undefined behavior looks when you're relying, when you wrote code that doesn't actually conform to the standard, and therefore, an optimizer may decide to change its behavior and break your code. And they're useful. Certainly the address sanitizer is very useful. The undefined behavior one is a bit more questionable. But they come at great cost, and this is compiling specific instrumentation into the code. It's hard to see how something like that can be turned on.
But the thing is that for those kinds of, there are all kinds of other things though that look for buffer overruns and counter overruns and those. But the thing is that those things, let's say that you cut down the number of errors that you do as a user by one set of tools, 90%. You hit the next bucket, you hit 90% of that. Very soon, your productivity goes up. You don't have this.
Well, I know, and that's what we've already seen with syntax coloring. We'll see it with Brenton stuff, et cetera, et cetera, et cetera. And I think with, the goal, I mean, look, the main point of this meeting was discussing, confirm, enclose, or whatever it's going to be called. And I think the general, it sounds like people think this is a good direction, but I think it's important to go inventory in more detail what some of the cases are. But one of the pieces of that is a confirm message or whatever it's called. And then the question is, how do we do that? Right? Can we do that in a meaningful way where we have, something which says, I just don't know how to do that. I mean, I don't know how to characterize types of messages. That's what we keep. Well,
I think at the first step you don't. I mean, so you have confirm message, which is basically your assertion as a programmer that I expect this block of code to not issue any messages. And as soon as it does, I need to take action.
Okay, but you see,
which then will also sort of help with the message spew sorts of things.
Okay, but to push back on that, let's say that you're writing some very critical piece of code, and you want to say and you want to be very kind of trigger happy about it. That is, if anything goes even possibly conceivably wrong, just fail, right? And you say, gosh, I wish you'd given me a message that you just multiplied by 0 to get 0 or something, but you didn't. There was no message because we didn't happen to have a message, on, off, whatever, right? So you're saying messages are little flags that go up that say something might have gone wrong here. And the question is, how persnickety, how pedantic do you want to be about looking for those messages? And sometimes, depending on the use case for your code, you might want to say, I mean, look, depends what the thing is doing. There are situations where the thing is flying a plane and the plane has to keep flying. And the fact that it generated a message, well, sorry, but or at some point it says, beep, 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 the human has to take over, right? But you have to, those kinds of things are, you've got to be able to determine what level of, you.
It's going to make you feel better. There are problems. So for power systems, they suffer message cascades that people are then not able to handle. That happened in Chernobyl, for instance.
Mm-hmm.
So in power, like electrical power.
Yeah, right.
So there are various places where those things are monitored, but often they're cascades. They're things that causes something else to fail,
Sure.
and there are huge cascades. And that's been very big focus. But those are very much safety kind of important.
Right, but so is that, Chernobyl is a famous story, but is there any reasonable way to think about that? I know that people it's like a warning light came on.
I'll have to dig in, but I think that what they basically tried to do is to construct that bigger, higher level picture of what the heck is going on, even though there's cascades of messages. And they built basically kind of like a graph model, one level up, so you can see the forest in spite of all the trees.
Okay, so what that is doing is what we were saying we didn't know how to do, which is like proof summarization.
Yes, effectively, that's what it's doing.
So that's a question. Given a spew of messages, given a giant cascade of messages, can you make a higher level conclusion from it?
Yeah. So that's what's been put resources into that area.
But so for us, I'm not sure how useful that is, because the most important thing for us is, well, what is the important thing? The important thing is your code has a bug, go fix it. Your code, there's something you didn't think about in your code. You can change your code to fix that. Another possibility is something kind of generally unexpected happened, and can you explain roughly what happened? I think that's less useful.
It's kind of like interpreting black box data when a plane crashes. All the information is there, but it still takes people months to figure it out.
Yes. Well, it's like, what does the accident report ultimately say? And it doesn't, have all the micro details probably of well, maybe they do actually. But I think that the question is for us, okay?
The other thing, if you want to build sort of reliable code, to stress it beforehand. And so can one build tools that makes it easier to stress it beforehand, so it's not so labor intensive, for instance, to do that?
Right. So one tool that I use for developing my parser has been fuzz testing is a big tool for stressing, beforehand, where your tool, it feeds whatever you're working on random input to see if it crashes and stuff like that. But crucially, it's not just purely random input, it's working with instrumented code so that it can see what paths your code takes depending on the input, and it chooses the random input in ways that tries to take different paths. And fuzz testing tools like AFL and libfuzzer and all these things are immense, like so incredibly useful for testing parsers, but also image, anything to do with file format, things that just take seemingly arbitrary input. So incredibly useful in
practice. That's a different category of discussion, is automated testing and what we can do for because users unfortunately rarely produce tests for code, and we've got a decent.
Yeah, but that's why I brought this up. Is there a way to? So first of all, we have made some things easier with those notebook testing.
It's an interesting idea, Brenton. A fuzz testing function might be an interesting idea. That is, you know that you've got f of 7, okay, and you use that as one example. Can you generate fuzz around that based on looking at the code and looking at inputs? I don't know whether that makes any sense, but that's a
and this touches on symbolic execution and other more complicated topics, but you could do something really basic if you are okay with running with instrumented code. If you loaded a package that you're working on in some special way that it instruments all of your code, everything around if statements and all the branches
Sure.
and everything that could take, then everything becomes a lot easier. Obviously still a lot of work to build.
Well, but so let me point out something that's an issue there. Let's say you've instrumented your code and you get the logging data from the instrumented code. The problem is, and that was the problem of Trace back in 1990, it generates wonderful logging data. It's just incomprehensible.
Oh yeah, no, I don't think a human would ever see anything that.
But then what does the machine look for? What is the machine looking for in those log files or logs? What is it looking for? What does it trigger on? How does it tell the story based on that?
Well, it knows, depending on an if statement, if it took one branch, it can kind of it has, very, it can apply backwards type of reasoning to, what had to have happened to take this branch. And so, do the opposite, whatever that condition is. Obviously you have to be specific, to take the other branch. And we're talking about symbolic execution. And this is well explored and, can be talked about, but a human would never see any of this going on. The human sees, when something fails or crashes, what that input was. And usually the human, the fuzz testing tool did, 100,000 man hours worth of work to generate one crash, with some input. And the human can usually just see what that single input was and almost know immediately what the problem is. And so, it's just a great kind of balance between, you do all the work over here, but only tell me at the very end what the input was, because that's really all that I care about. I can step through later with, that input and reconstruct, whatever that whole
No, I think it's an interesting idea. Somebody should try and make a sort of candidate top-level fuzz testing thing. Hey, listen, let's just make a note a few things on the live.
By the way, Brenton, that's exactly how verification of discrete systems work. What you generate is one trace or failure trace, and those might be very deep, which means that you can't even test your way to them because it's just way too expensive to even get to that level of coverage testing wise.
So that's
for high reliability kinds of systems.
Various people on our live stream are talking about quick check. I don't know what it is, but this seems to be its page. Does people know about this? Oh, I see. Okay, so this is a generator of tests.
This would be yet another avenue to take, yeah.
Right. I mean, so this is just basically type specifications and generating random input based on type specification in some sense.
Yeah. So random generators of more kinds is generally useful in this context. And we're steadily producing more of them.
In the world, I always bring this up, and just because I'm silly, but in the world of ancient things, SMP had a random expression generator. Oh, drat, don't have it. But that was an idea. Back in the time of SMP, I had a mechanism for generating, random expressions.
Was that like random or no? It had
it was a function.
Names.
It was called Rex. The random. SMP had short function names. Another bad idea, but it was. I have to just bring up its documentation. I wish I could actually run it. Why can't I run it? So I thought I had a way to.
Maybe you don't have a VAX machine.
No. I have a way to do this. So run smp.app. Here we go. Let's see. Ta-da! Clock gained. What on earth is this? I don't even know what this. Check and reset the date. It might be off by 50 years or so, 40 years. Oh no! Checking for. Oh. Psh.
Isn't it? It's something. Wow. Okay.
Something very generic.
Something trivial on your.
For you.
Oh, it would run on BSD Unix. That's almost modern.
I think it's nothing. No. SW and then just press enter.
Okay. Drat.
That 4.3 BSD Unix, is that like Sun OS in the 80s or something?
It says 1987 here, Friday 1987.
Yeah. Oh, okay.
If I remember right, this is running in like multiple levels of VM.
I think it's honest to goodness Berkeley Unix, because Sun was based on 4.x, but it would identify itself as Sun OS.
Oh, okay.
Now that I'm challenged here, I'm going to see if I can actually run this. Hold on 1 second. Let me look up. Here we go. There we go. That's the answer. There we go. Just used root.
You have new mail.
What's that? You have new mail from 1986. I hate to even imagine what that could possibly be. But anyway.
It might be your printer demon complaining about it can't connect to the printer.
Look at this. So this
it seems like you also have a War Games demon or something as well.
But the thing is, Stephen, as interesting as that is, it's
useless. I mean, it's
right.
Useless.
That's what I was going to say. It's
absolutely useless. The question is how to make this useful. So there is a random. Oh wow! Look at that.
Yeah, if there was some grammar to help it along.
Exactly. But we often need sort of constraints on other levels in the grammar too. So it's not pure grammar.
Yeah.
Do you know what I'm saying? Because they're often semantic constraints too, to be able to feed this function or whatever it is.
Right.
Right. Like being positive semi-definite is not a grammar property. That's what I'm saying.
Yeah, I mean, people. Okay, so the various comments on our live stream. I just want to highlight some of these. So this idea of a framework for generating tests, clearly a useful thing, and we should explore that some more. And this random expression based on grammars is an interesting direction, but we can probably do things. I mean, expression grammars is not something we've particularly been concerned about. We've mostly been concerned about computing things from expressions rather than characterizing. Well, I guess we have patterns, which are expression grammars in some sense. Right. And now we have types for the compiler, which is also something along the same lines. Hey, on our live stream, Ethan is commenting on extending message beyond strings. Heck, yes, we need that. And I don't think people in this, maybe somebody in this meeting can comment on that, why it's been so hard to extend message to work for things other than strings.
In which sense?
What other things?
Having the payload for a message, function : thing.
You mean message name?
Yes, message name. The value of message name not being.
Well, for one thing, everything in it, all the code assumes it's a string. I mean, I'm not sure exactly how hard, but you'd need somebody to spend however long doing it. I'm not sure.
Well, it's a question of adding another level of indirection. I mean, there are engineering solutions I can imagine that would just add another level of indirection. I mean, we already have message blah 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 : language, for example. And I could imagine adding something, as a way to do the engineering. I could imagine various kinds of ways to do the engineering, but I mean, I know that's an issue, and no, this is when we're not talking about making the second argument of message name not a string. We're talking about the actual message that comes back, the template for the message being not a string, so that you could actually have a message that has a table or a graphic in it, which you can only do by including it as through string templates. Let's see. So there are concerns that the existing testing framework isn't good enough. We agree. I mean,
should a movie come back as a message? I will show you a movie. Here it is.
Well, yes. Just wait for some stuff happening in Wolfram Alpha along those lines. Let's see. So someone's commenting on here about the testing framework and exception handling framework. Yeah, the whole subject of this meeting was about exception handling. Let's see. Verbosely should be called loud since we already have quiet. Interesting. There's one comment here. How about
and in fact, you can sort of do that already, right? Because you can there's a third argument of quiet, which is to unquiet. So you can sort of unquiet everything if you really want to.
And there are questions about there's a comment here about community-driven error feedback system. Yeah, I mean, I'm not quite sure what that really is. I mean, I think, there are things we know, for example, in the Elementary Introduction to Wolfram Language book, which has an online auto-graded code system, we do know, Rick here, I think, would be able to comment on that, but I mean, we do know a lot of stuff about bad code that has been entered in that. Is that a fair statement, Rick?
Yeah, I mean, we have the data to figure out the bad stuff people do.
Right, but I mean, but the point there is that is a data set of, this is a piece of semantic, this is something that was semantically aimed for. This is what actually happened. And that's an interesting data set because it tells us the types of errors people make. And we looked, I guess we haven't looked so much at that. We looked at some stuff to do with the problem generator for math problems. I guess we haven't. Have we looked at the code errors there? And because that's an interesting question. Another famous example of how not to handle error messages, and we should wrap up in a moment, but I have to show you this because it's one of my favorite design mistake stories. Let's see, this is SMP documentation, and I can show you the category, and the category of a thing not to do. Okay, this is one of those things not to do stories. At the end here, oh come on, I have to show you this. This stuff is okay. This was stuff that we finally have got in Wolfram language. We've got except we don't have that. We don't have ASCII art. Large product signs. We've never had a product sign in ASCII art. Let's see, how do I get this to go back? Oh gosh. Oh, here we go. This someplace here. Where was this? This is probably full of weird stuff, but where was it? This probably has funny stuff in it from implementation of, but what I'm looking for is a page that was called there's a page called things that can go wrong, basically.
I think it's about something suspected errors.
Yeah, that might be it. No, you see, that was the report of a suspected error. The fascinating thing was I had a page in the documentation which was basically things that could go wrong, and that page, people were very confused about whether that page was why is this PDF so unbelievably slow? Is there a way to get it to display thumbnails? Somebody know how this works?
No, not in Chrome.
Oh, I'd have to open it in oh, I see what you're saying. If I opened it in an actual PDF reader, I would get this to work. I don't know. It's maybe not worth showing, but it's quite an interesting thing because it had a list of possible things that people could do wrong, and that was the worst thing you can possibly document because people simply remembered the things that they could do wrong. In other words, they didn't remember the right way to do it. They remembered the possible error.
Mm-hmm. Right. It's like one of our friends complains that whenever she tells her husband to go to the store and he can buy everything except the pumpernickel bread, guess which bread comes home.
Right. I mean, I think it's one of those cognitive things. Let's see, I'm almost there. Now I'm frustrated. I've got to find this. I'm almost at it, I'm sure. There's some. Come on, I gotta get.
Is this a TROF thing or is this?
This was TROF. No, this was TROF. Back in the day.
Ooh, I remember TROF.
well, I seem to have lost this, but in any case, I wonder what I would have called it. Potential. No. Well, that was fun. I noticed an acknowledgement to Rob Pike there of talking of programming languages, who was the person who persuaded me that C was the language of the future. Is the author of Go, for people who know programming language history. Okay, well, I'm not finding this, but oh, here we go. There we go. I finally found it just as I was about to wrap up here. Some common difficulties. This was such a profoundly bad idea because, this is number one, was a system-defined projection that's a function returned unsimplified, unevaluated when evaluation is expected. And a strange result involving unexpected objects is obtained. Says you probably
we have an analog of this today. We call it possible issues on reference pages.
We do, yes, we do. But for some reason, that hasn't caused the same problem.
No, but the point is that we're trying to sort of either explain that or how to solve it, if you have it.
Yes, right. Right. I mean, well, this is doing that too. But the problem with this was, it became kind of a short summary of 10 things you need to know, and the 10 things you need to know here ended up being things that are, things that you got wrong.
Right.
Anyway, okay. So listen, just summarizing this meeting, it sounds like Christopher should go and try and learn about does anybody here have particular error handling code or ideas that Christopher should make sure to inventory? Like particularly anybody who has a framework with actual functions that do error handling. That's a deafening silence. Okay, but so there are conventions which have been discussed in this meeting for how to do the throw, catch, error handling, and so on. Does anybody use anything other than throw and catch as their way of doing production error handling?
Handler block for messages. Sometimes I use that for things that's related.
Okay, what is handler block? What is that?
So you can basically pass a function for when a message would print, like do something with it.
Is that a built-in function?
It's internal. It's an internal function. And it basically it's a handle for various types of events, of which one is messages.
Okay, that sounds like another thing Christopher should know about if he doesn't already. Do you know about that?
Yeah, I know about it. And that's how, for example, there's a function that's used for like guard message, and the prototype version, which is the general utility is with message handler, which I think just calls this.
Okay. All right. Well,
might be nice if we had some internal documentation about handler block.
Well, let's hope we can expose what's relevant from it at top level. All right. Well, good. Thanks, everybody. And somebody's suggesting looking at F# error handling. Don't know anything about it, but maybe. Yeah, I know that Microsoft has done a lot of work on sort of programming language analysis. Okay. Well, good. Thanks, everybody. And thanks to folks on the live stream. Lots of interesting and good comments here. Much appreciated. See you all soon.